there are four critical changes happening in our environment, and these changes can be seen right there in the city where you live. One of those changes to the environment, and these are not good changes, by the way, these are changes that we need to quickly turn our attention to prevent further threats to biodiversity. One of those is going to be nutrient enrichment. Human activity has a tendency of removing nutrients from one part of the biosphere and taking them to another. A classic example is the growing of fruits and vegetables, agriculture. The things we eat are bringing nutrients to the place where we live, but those nutrients are coming sometimes from other states and even other countries. And so the lands where food is grown is having those nutrients being extracted and exported to other different places. Another example of the nutrient enrichment that is taking place is that wherever agriculture is happening, farmers often have to apply fertilizers to enhance the productivity of the land. And what happens with all of that nutrient is that it is not used by the plants, and it can reach to a point of a critical load, which happens to be the amount of nutrient that can be added and will be absorbed by the plants without damaging the quality of the ecosystem. But if too much nutrient is added, like in the case of golf courses, where to keep the grass green, it requires insane amounts of ammonium nitrates and ammonium sulfate and other kinds of fertilizers to keep the grass green. What happens is that all of those nutrients that are not used by the plants are washed away by the rain and the runoff that reaches the drainage of the cities, eventually carries it to rivers and to the oceans, where it will quickly be accumulating in aquatic ecosystems. As you learned in the previous chapter, the chapter dealing with the nutrient cycling in the ecosystem ecology, is that when aquatic ecosystems become overloaded with nutrients, particularly nitrogen nutrients, this is going to lead to a problem called eutrophication. Eutrophication is all of these nutrients that lead to a phytoplankton bloom, like an algal bloom. The water's turned green or turquoise in color. It may look pretty, but it often comes with an awful smell, the smell of decay, the smell of death. And the reason is that when the algal bloom happens, the phytoplankton eventually dies, and things that die are decomposed. And the bacteria that are in charge of decomposition use a lot of the oxygen in the water where phytoplankton, where algae is dying. And when all the oxygen in the water is depleted, then everything in the water dies. The crustaceans, the fish, other aquatic plants that may be living in shallow portions of the aquatic ecosystem. And when everything dies, then that's a real threat to the health of the um, overall ecosystem, and also to the health of humans. So that's one of the problems we have right now with nutrient enrichment. Nutrients taken out of one place and put into another place, and sometimes the excessive amount of those nutrients that ends up in the aquatic ecosystems. Another type of environmental change that we should be concerned and do our part in minimizing this is the production and the release of toxins in the environment. These toxins are going to be absorbed by the soil and sometimes by plants or in aquatic ecosystems. They are going to be consumed by phytoplankton, by algae. And then the phytoplankton in turn provides food to zooplankton. Zooplankton are going to be the larval stages. Excuse me, I'm trying to get my laser pointer so I can then magnify this illustration. Okay, here we go. Phytoplankton, this is algae. These are primary producers in the ecosystem. And so they take these chemical toxins and incorporate them into their cells. Then when these are consumed by zooplankton, the larval forms of animals or small crustaceans like Daphnia. You see some kinds of shrimp over here too. Then those accumulate and magnify the amount of toxins into their bodies. Remember that for any level, trophic level in the ecosystem, the amount of energy that used to be available at the previous level is going to be 10 times. And so when these animals, the zooplankton, are consuming the phytoplankton, they're going to be magnifying at least 10 times the amount of toxins in the amount of food that they had previously consumed. Then the zooplankton is going to be consumed by fish, fish which are eaten by larger fish, and those fish are eventually eaten by birds. And at every level, as you go up the trophic structure of the ecosystem, as you go from one trophic level to the next one and to the next one higher up, there's going to be this magnification of the toxins that are in the environment. Of particular interest here is going to be PCBs, the polychlorinated biphenyls. Those are going to be compounds that are really bad for the health of organisms and also to humans. DDT is another example. You can go and look about the effect of DDT on birds of prey, particularly peregrine falcons, bald eagles, and many others that were feeding on fish, and how that led to the decline of populations almost to the point of extinction. This is something happening back in the 1970s and 1980s. The ban of the use of DDT has allowed for many of these species to recover, and DDT continues to be banned here in the United States, but it has not been banned in other countries. So that threat continues to exist for populations of birds and animals, wildlife that don't know the boundaries between the ocean that belongs to one country and the ocean that belongs to another one. Biological species are highly mobile in that way. So, and you may say, how can I help cut back on the amount of toxins? And the answer is going to be relatively simple, but it's one that should deserve a greater conversation. Is the answer is consume fewer things. The level of consumerism, the amount of things that we consume, lead to greater activity in industries, and industrial activity and manufacturing is what leads to the increase in the production of some of these toxins that are now part of the environment. Other toxins include pharmaceutical drugs. They go into the fresh water, into streams, into lakes, and one of those that are particularly interesting is sex steroids, the same estrogen that is used for birth control that ends up in the sewage, and the sewage sometimes is treated, but the treatment doesn't remove completely all of these chemicals, so they are in the water people drink. And there are studies that are beginning to reveal that some of the fertility problems seen in some populations, in some people, may be related to sex steroids that are present in the water that is running through the pipes of towns and cities. In the case of fish, the ratio of males to females in fish has changed because of all that estrogen in the water. There's going to be a greater ratio of females, and those females often are not able to complete the reproductive cycles. And so for several species of fish in places where you have this type of toxin, their life cycles and the populations are life cycles are affected and population numbers are going down. Plastics is another problem. We all know about plastics. About 4.8 to 12.7 million metric tons enter the oceans every year. It doesn't completely degrade, but sometimes the plastics break into smaller pieces, and those microplastics are consumed by fish, are consumed by birds, and they're moving up the trophic levels in food chains that sometimes end up producing some of the food that we consume. So it's another alarming type of toxin that is going into the environmental change, and we should be concerned about that. Plastic in the oceans leads to greater rates of disease in coral reefs. You can see here an example of corals that are wrapped around in plastic, and the disease that usually afflicts these colonies of cnidarians is due to microbes, bacteria that are living in the plastic. And then this is how those pathogens are transmitted to the corals. The pathogens, the bacteria that are clinging to the plastic, that ends up clinging eventually to the coral. One more environmental change that should be of concern to us is going to be the emission of greenhouse gases and climate change. And we can see that since the 1960s all the way down to 2020, the trend continues to go up. The data you see here in this graph shows that as the temperature, as the CO2 levels increase, temperatures continue to increase. And according to some estimates, the average global temperature has increased by about almost 1 degree Celsius, 0.9 degrees Celsius since the 1900s. That's about 1.6 degrees Fahrenheit. And as a consequence of this, everything else, we see the melting of the glaciers, the permafrost up in the Arctic zone is also melting, and that is going to end up releasing more carbon into the atmosphere. And it's, high CO2 levels, the enhancing of the greenhouse effect, these gases that are trapping more of the heat that should be escaping back out to space is one that can eventually change the landscape of our planet as ocean levels rise. So you may say, hey, I don't live near the ocean. Well, other weather events like severe droughts that are so extensive now throughout a good part of the southwest of the United States, severe weather like hurricanes and tornadoes that are happening in the middle part of the country, that's the tornadoes, and on the eastern seaboard, we see the hurricanes. They are becoming more and more powerful, more destructive, and more frequent. All of those are the consequence of global climate change. One more climate change that is alarming to us is the depletion of the ozone layer. This is one that we probably have some encouraging news, although the ozone levels have decreased for around 2 to 10% over the past 20 years. Countries, nations have taken initiatives to eliminate or reduce significantly the release of industrial chlorofluorocarbons, CFCs, which when they go into the atmosphere combine with ozone, which is O3, and produce O2, but this is not the kind of O2 we want to have. We actually need the O3, the ozone, up in the upper atmosphere to block the ultraviolet radiation that comes into this planet. Higher levels of UV rays can have negative impacts on humans, higher rates of skin cancer, and also higher levels of UV rays can also affect the health of plants, damage photosynthetic tissue in plants. And so all of these problems that come from the depletion of the ozone layer have made nations, as I said before, react, respond, and reduce the amount of these chlorofluorocarbons that are being released. And that's a good thing. One of the things that I want to leave you with in your minds is that anything you can do in terms of conservation, don't think that, hey, I'm just one person, what impact can that have? The impact of individuals, if we all did a little bit in terms of conserving resources, not taking excessively things that are needed by other organisms in their natural habitats, that is something that will help preserve biodiversity in this planet. And in the long run, it's going to make the quality of life for every living thing on Earth much, much better.